He would have. Turn it back on. All right, so let's jump right in. So, Chapter 6 is all about production processes and production costs, okay? So what do we mean by that? Well, essentially, right, when we go out in the real world, we're going to have, some sort of production process, right? And the book talks about an engineering relation, right? And so they define a production function. They say an engineering relation. You can also call it a mathematical formula. That does what? It defines the maximum amount of output that can be produced with a given set of inputs. And the inputs we're going to use in this example, it's going to be our standard big clumpy kind of groups, right? We're going to have capital, which is going to be abbreviated with a K, and labor, which is abbreviated with an L. So what is this production function? So remember before, right, we had y equals mx plus b, right? And m and b were constants, x was the only other variable, right? So the other way we would say that this is a function of x, right? So in a similar way, now instead of just having one argument in that function term, we have two arguments. So instead of using a lowercase f, we're going to use an uppercase f, and it's going to be a function of capital and labor. So these are two separate inputs that combine in some way to make the quantity produced. So when we're talking about production, right, when we're talking about economic stuff, we are usually going to talk about periods, right? We're going to talk about the short run period and the long run period. And what do we mean when we talk about periods? So let's talk about that real quick. What is the short run? So the short run is literally defined as the period of time where some factors of production so otherwise known as what? Inputs are fixed. And so because they're fixed, they do what? They constrain a manager's decision. So the short run is defined by the fact that something is fixed. I cannot alter something. And for the most part, when we talk about the short run, we're going to talk about how our capital, right? So essentially, you can build a car with 10 workers and 1 robot, or you can build a car with 3 workers and 2 robots, right? And so, but in order to get that extra robot and finance it and have it produced and shipped there, it takes time, right? So that's essentially the thing that's going to be constrained. So we're going to have a short run production function that's going to look like this. Q equals little f, because it's a single argument function. And so we know that this is equal to big F with a K star, where K star doesn't mean equilibrium or anything like that. It means a fixed amount of capital. We only have so many robots, right? We can't just go and buy a new robot from the robot store. It takes some time. Which leads us to our next definition, which is the long run. So the long run is this period of time over which all factors of production also known as inputs, right, are variable. And so variable means what? That means the manager can adjust them as necessary, as they see fit. All right, so the long run, that's going to have our normal kind of production function, right? Our long run is going to be Q equals F of K and L, where neither one of them is fixed. So questions on short run, long run, how that integrates with variable and fixed costs. So remember, fixed costs cannot be changed in the short run, but can be changed in the long run. It's not defined by a period of time, it's defined by my production process. Your long run might be 7 years, my long run might be 2 months. Okay? Let's keep that in mind. All right, different measures of productivity. So this should be pretty standard for all of us, right? But just so that we have a complete note set here, right? Our total product, also known as TP, giggle, giggle. This is the maximum level of output that can be produced with some given amount of inputs. So it's just that Q number, right? Total product, boop, is that Q, right? Simple as that. What about average product? So when we see average, essentially the hack there is whatever the next thing is after average, we're going to take that thing and we're going to divide it by some unit, right? So the average product, so this is going to be, we're going to have two different kinds actually. So the first one that we're going to have is a average product of labor, which is equal to my quantity divided by my number of laborers. So if I make 100 cars in a day and I've got 10 laborers, my average product of labor is 100 divided by 10, right? If I have one robot, right, so I've got one piece of capital and I produce 100 a day, then my average product of capital is 1. So these average products are just a measure of the output produced per unit of input. Now the last one, the most important when it comes to economics, because economics is all about incremental analysis, which is also known as marginal analysis, right? We're talking about stuff on the margin. We're taking a look at things not in the lump sum, but we're taking a look at things like we step in, the factory's already producing so much, and we're looking at whether or not we should increase or decrease that production amount. So we're going to do this incremental analysis with our marginal product, which is the change in the total product attributable to the last unit of an input. And so our marginal product, and we're going to do examples of this, make it a bit clearer. So again, we have two of these, just like we have two of the average product of labor, right? We've got a marginal product of labor that's equal to my change in my quantity. So we're going to use this delta symbol. So this math notation here, delta Q, my change in the quantity divided by my change in the labor. And then my marginal product of capital is equal to my change in my quantity, or total product, divided by my change in my capital. Oh, that one looks like a volcano. So let's go ahead and do a couple of examples. And then there's a chart that we're going to go ahead, or not a chart, a table that we're going to go ahead and recreate in Excel and take a look at kind of what these graphs do over time so we understand them. But before we do that, let's just do a couple little quizzes on our own. So consider the following production function where we've got 10 units of labor and 5 units of labor, 10 units of capital. So the first one is going to be our capital. The second one is going to be our labor. Oh, cool. This one's also alphabetical numerical, right? H-I-J-K-L-M-N-O-P. So it just goes according to the alphabet, just like with the P and the Q, with the labeling and stuff, right? Nice. So the production function here is going to be 150 doll hairs, or output, not doll hairs, units, widgets, whatever they are. So compute the average product of labor. What is our average product of labor? And then while we're at it, let's go ahead and compute the average product of capital. All right, so for capital, let's go do capital first. It's going to be our total output, our 150, divided by what? Our units of capital, which is 10. 150 divided by 10 is no more than what? 15. My average product of capital then is 15. Is 15. All right, what about the average product of labor? We're going to take 150. We're going to divide that by 5. 150 divided by 5, that's 30. Very good. My average product of labor is going to be 30. Excellent. So let's go ahead and take a break from our notes and jump into Excel real quick so that we can look at these things in a better way. So over here we've got the value of, we've got labor. And then over here we've got the price of output. So we're going to get to that in a second. Let me zoom in a little bit here. I need more than that. The price of the output. Here's my marginal product of labor. And we won't get to the rest right now. Let's just go ahead and set this up and then we'll get back to our notes. So our value of labor, 0, 1, 2. So this is this goes all the way to 11, just like the best guitar amps. And the price of the output, right? We're assuming that what is this called when the price doesn't change regardless of the output that you have, how many you're producing? You're a price taker, right? So it's a given price, you're a price taker. All right, so our marginal product of labor, oh, hold on, wait. To figure this out, I knew it. I was like, wait, I jumped ahead. So that was table 2. So let's go ahead. So this marginal product of labor, that's going to go over, all the way over here, actually. So we've got some other stuff to do real quick. We've got output, Q, and then we've got change in labor, and then we've got the marginal product of labor. Okay. All right, so we're given output as well. We're told at first it's 0, then it's 76, then it's 248, 492, 784, 1100, 1416, 1708, 1952, 2124, 2200, 2156. And our change in labor, so it's important that this is a column in and of itself, even though what's our change in labor for each one of these things? 1. Right? But if we wanted to like program this properly, right, we would do what? We would say equal to Gesundheit, not equal to Gesundheit, equal to this one minus this one, right? To take a look at the changes in labor. Because what if instead of having it be 1, 2, 3, I had it be 5, 10, 15, 20, right? So having it be this formula allows it to adjust. You know, sometimes it's not going to be constant too. It might be something like this, right? Goes up by 5, then 3, then by 4. So it's important for us to keep in mind that when we're calculating the marginal product of labor, it's not just the change in the quantity, it's divided by the change in the labor, right? So let's go ahead and calculate the change in the quantity. So the change in the quantity is going to be what? This cell minus this cell. C4 minus C3. And this one is A4 minus A3, right? For that formula, right below. So this we can just go ahead and drag to the bottom, right? The other thing we could do, Excel is super cool, you can just double click it, and it'll populate it all the way to wherever the left column is. So if this were to continue, it would go down however far this is. And so we see here that our change in our quantity is for the most part positive, right? Every time we add a new labor, we're having an increase in the quantity, and the rate at which quantity is increasing up until a point, right? Up until we get to adding the 5th and 6th laborers. The 5th laborer adds 316 units to output, right? And the 6th laborer does the same. And so now let's go ahead and calculate our marginal product of labor. It's just our change in our quantity divided by our change in our labor. So for this case, it's going to be the same exact thing as our change in our quantity, which is why this column is not given in table 5.1, which is what we're recreating here on page 139. So we really don't need this one. We can go ahead and hide it. And we end up with a marginal product of labor over here, which is rising to a point, peaks, falls, and then becomes negative at some point. So what do we call this phenomenon where I add more workers, and the rate at which I add more workers, the rate at which it increases my productivity goes down? I heard it somewhere. Diminishing marginal returns. Diminishing marginal returns, absolutely. So you're going to get marginal returns at first, that's 76, right? And then it's going to increase and increase and increase. But at a certain point, we're in the short run here, right? We can only alter the labor. We can't alter the capital. The capital that we have is fixed. So what does that mean? That means that adding more and more and more people to the same space, or adding more and more and more people to the assembly floor when we only have one robot, is not going to increase production by as much as it used to, right? It used to increase production by 316 when we added the 6th worker, but now when we add the 8th worker, it only increases production by 244 units. And then it gets to a certain point where at 11, we actually get negative returns, right? Adding that 11th worker takes away labor. So what's going on there? So the book has a great example. Talks about studying on the top of page 142, right? And how, you know, if you study 0 hours, you might make a 75 on some exam, right? And if you study 10 hours, then you might get, you'll get a 0 if you don't study. You'll get a 75 if you study for 10 hours. So the marginal product of studying those first 10 hours is that 75 points. Then it says, well, studying an extra 10 hours you'll get 100 on the exam. So if you study for 20 hours, you'll get 100 on the exam. So the marginal product of the second 10 hours is that 25 points, right? The difference between 100 and 75. Then it talks about how, if you've ever pulled an all-nighter, ended up sleeping all night, or really performing poorly on an exam due to lack of sleep, then you've actually been in this range of negative returns, right? You have gone past a productive phase in your studying, and that extra hour that you pushed for between 3 and 4 in the morning, you should have just went to sleep, right? And so it actually ended up decreasing your score because you were tired and you were distracted and stuff like that. So in our example here, you add more people, they're going to bump into each other, right? They're going to fall. They're going to, things are going to get broken, or things are going to get lost, or people are going to be talking too much in the break room. There's a lot of different reasons why. But essentially, in the short run, we are constrained by something that makes it so that the marginal product can't increase forever. It increases up to a certain point, and then decreases, and then goes past 0. All right, so let's go back to notes. So looking at that graphically, looks like something like this. We've got a total production that does this. So for those of you that are mathy, it's convex at the beginning, then concave, and then it goes down. And I actually did a little bit too exaggerated, but there's increasing returns, then there's an inflection point, then there's some sort of maximum, then there's a slight decrease. And where this maximum is, I need to make a note of that spot, because that's where my marginal product should be going negative, right? So my marginal product follows this. It's just smaller. So those are the graphical interpretations of the example that we just did, table 5-1. All right, moving right along. 11:28 already. Cool. Oh yeah, we need to label these parts. Excuse me real quick. So up until this inflection point, right, where the third derivative turns is 0. So this is increasing. So when it's convex, it's increasing marginal. Oh, and I drew this. Hold on, I got to redraw this green one. Marginal returns to labor. It'll be clearer when I redraw the green line. Green line, green line. Won't you be better, green line? Nope, still not good. So this should be the peak of the marginal revenue. And so that it makes sense that it's increasing marginal returns to labor during this period, right? It's going to be decreasing marginal returns to labor when the marginal returns are still positive. And then lastly, over here, right, when the marginal returns are below and when total production is going down, the more labor that we're adding, this is our negative marginal returns to labor. So I'll spell it MRL all caps, or MR sub L, which is what you'll see the book and stuff. It's the same exact thing. These are equivalent. Very equivalent. All right, so what's our role in this whole shenanigan situation, right? Why do we care? Well, as managers, right, as future managers, we have to produce output at a certain rate with this production function, right? So the book talks a little bit about, there's this like small paragraph. It's kind of like a segue to chapter 6, if we get there. It's about, managing worker effort, right? And essentially part of your job as a manager, right? Just by definition, you're managing workers. And so you have to make sure that the workers aren't shirking, right? You have to make sure that there's some sort of either incentive schema or some sort of disciplinary mechanism or oversight mechanism, right? So that's why, the Amazon people, they have sensors on them with GPS that's like keeping track of how quickly it takes from them to run from one place to another, right? That's why waiters and waitresses get paid so low, because there's an incentivization for them to do really well, because everybody knows their wages are based mostly on what? Tips, right? And so that's a way to keep workers, to induce maximum worker effort. But, so that's chapter 6, and we'll get to that. But right now, chapter 5, what we're more concerned with is we are concerned with using the right mix of inputs to maximize profits. So, in order to talk about this, we need to introduce a new variable called the value of the marginal product of labor. And so the value of the marginal product of labor is abbreviated with VMPL, and it's no more than my marginal product of labor times whatever the price is of that final good. And so to maximize profits, the manager will hire labor up until the value of the marginal product of labor is greater than or equal to the wage. So we're going to go over an example of this in a second. We'll go back to our Excel example. So what's our value of the marginal product of labor? What's the first one? You don't have to do the math. Just tell me what's multiplied by what? 76 times the price. Very good. So we take this 76, we multiply it by the price. And so we're going to go ahead and we'll double click that. We'll do a spot check. Make sure. All right. It's doing its thing there. Awesome. Go ahead and we can write the formula up here if you want. F4 times B4. B4. Plain bingo. This one's D4 divided by E4. And then we're given a wage. We are given a wage. Let me, I'm entertaining myself. Wage. So this is another thing that's given. We're told that every labor costs $400. So, excuse me. This is where the book's example sucks. Because essentially, you look at this immediately and you're like, wait a second, the value of the marginal product of labor is immediately less than the wage, right? So that's why they made the definition a weird thing that's like you're going to hire until the value of the marginal product of labor is greater than or equal to wage rate. So Essentially, there's this like small part at the beginning of most of these production processes where you're still ramping stuff up, and so the value of the marginal, like the first or second worker, it's not very representative, and so you're not going to stop there, right? So we're going to go to the second worker, right? And we're going to say, okay, the second one, the value of that is 516. Is that greater than 400? You bet your bottom dollar it is, right? So am I going to hire this second worker? The answer is yes, right? And then I'm going to say the same thing in 6. Is 732 greater than 40, right? Yes. So the question I'm asking here is the VML greater than the wage? Yes, 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 yes. No. So they are going to hire 9 laborers in order to maximize the profits. So this is the example of how to do this kind of profit maximization through input choice. So you're incrementally analyzing as you increase the number of laborers, right? And again, this example sucks because that first one, you know, it's not above it, right? So this is actually technically no, but we're going to say no. But since it is above 400 for workers 2 and 3, I will hire the first worker anyway. Which is like kind of the same excuse that the book uses. I don't know why they just didn't give you a better example. I mean, part of it has to do with the fact that, so I was just teaching this in Econ class yesterday to my 200 level class. And we are going to get there on Friday when we talk about costs and the cost functions and things like that, right? So part of it has to do with the fact that, so this is kind of so I'm just jumping ahead real quick to just figure 5-12, right? It's talking about the relationship between the average and the marginal cost curve. And there's this little portion. There's this little portion of the marginal cost curve, right? It's this Nike swoosh section here, and that's not a good job. So the reason why I redid that is because I need this marginal cost to go right through the very, very bottom of that average total cost curve. So there's this part over here, right? This weird part of the Nike swoosh, right? And so what happens when the price falls so low that it goes through both of these? The marginal revenue or the demand curve or the market price, right, if we're price takers. Well, we know from simple economics we're always going to produce where the marginal revenue equals the marginal cost, but here there's actually 2 different points, right? So in the same kind of vein, like we don't really use this portion of the marginal cost curve, and in the same way we don't really use this portion. Oh, I didn't know I could draw on here too. That's cool. This portion of the value marginal product of labor curve. Okay, cool. Back to notes. All right, so in a similar vein, with capital, right, you're going to hire or sorry, what does it say? Does it say hire? Let's just say acquire, just to use some different words, right? Acquire or buy capital goods until the value of the marginal product of capital, which is, you got it, is just the marginal product of capital times the price, is equal to what's called the rental rate. So the rental rate could be the cost of it divided by the years that you can amortize it, right? So if it's like a long-term capital good that you can amortize over 10 years and it costs $10,000, then the rental rate's going to be $1,000 a year or something, right? But the rental rate could also just be the actual rental rate. You might be renting it from somebody. And so you're only going to rent an extra machine if the value that extra machine in terms of the price of it times the amount of output is greater than or equal to the rental rate. All right, let's talk about the 3 different types of production functions, and then we'll take our Kahoot quiz for today. Call it a day. Get everybody some attendance points. So we have 3 commonly used algebraic, your favorite, production function, what's your junction, forms. So the first one that we have is the one that if we all, gun to our head, we had to come up with one, we'd probably come up with this one. It's called the linear one, right? This is assuming a perfect linear relationship between all inputs and total output. So this is not the case, right? We know this is not the case in the real world, but like so many things in economics, all models are toy models, right? We have to make some limiting assumptions. And so really this is just a baseline too for us too. This is an extreme, all right? So this is an extreme, and it's our simplest extreme. It's a Q equals big F, not little f, big F, because I got 2 arguments here, capital and labor. And it's going to be equal to A times capital plus B times labor, where A and B are some constants. Doesn't matter. Doesn't have to do with prices, right? It has to do with how productive they are in the production process, the engineering relation, right? The second type of commonly used algebraic production function forms, say that 5 times fast, is Leontief. So named after the gentleman who came up with this type of production form. This one is probably going to hurt your head a little bit. This one assumes that inputs are used in fixed proportions. How does that work? Well, sometimes you need a certain amount of capital and a certain amount of labor, and adding extra labor doesn't actually increase production at all, right? Because you need capital and labor 1 for 1. You need both of them at the same rate. And so we represent this by Q equals big F KL equal to minimum of these 2 functions. So either A times K or B times L. And again, A and B are some constants. So same thing going on here. And our last one before we put our notes away for our quiz, we've got the one that's in between. So this Leontief looks something like this. Leontief, Leontief. So Leontief looks like this. Q0, Q1, Q2, right? So essentially I need this amount of capital and labor in order to produce this amount of quantity. Increasing the amount of labor isn't going to increase my amount of quantity unless I also increase it with a corresponding amount of capital. So that's what this is saying. Each one of these corresponds to a different amount of quantity, and this has to do with, this is 3 units of labor, 3 units of capital and 10 laborers working. So this other one, right, the one where they are perfectly substitutable, that one's going to look like this. right? If I wanted to, I could produce with all the capital and none of the labor in order to get Q2. I could produce half and half, or I could produce all labor, no capital. And so these are our two extremes. In reality, it's something in between what's going on in these extremes, and that something in between is not just named for one person, it's named for two people. So this is called the Cobb-Douglas, because they both came up with it together, production function. And this assumes some degree of substitutability among inputs. And so this looks like maybe your worst nightmare, hopefully not. So it's going to be capital to the A power times labor to the B power. And this is the gold standard. This is pretty much all I worked with in economics when I was doing this kind of stuff in grad school. It was all Cobb-Douglas production functions. We never did linear functions. We very, very rarely did a Leonti function. So this is the bulk of what we're going to be focusing on too in class on Friday. We're going to be dealing with how do we figure out the marginal product of something like this? How do we evaluate the output when we're given, A and B as some constants, and we're given a certain amount of capital and labor that are employed. So if this is unfamiliar, please go ahead and read all the way up until page 148. So we'll pick up on page 148 in class next time. All right, let's go ahead and